Okay, in 5.5, we've already done the rational root theorem, which you have the P over Q, and you make that list of all the possible rational roots. Now we're given another theorem, the fundamental theorem of algebra. And what that says is if you have a polynomial where degree is greater than 1, it has exactly n roots, or n zeros. So the number of roots or zeros is the same as the degree. So whatever the degree is, that's how many roots there are, that's how many zeros there are. Now that's including multiple roots, meaning the multiplicities, and it's also including the complex roots, meaning the i's, the imaginary zeros. So what we're going to use that theorem along with the possible rational root theorem to find rational roots of a polynomial that we're not able to factor. So for this first polynomial, I have this cubic, and it's 4 terms, but if I try to go use the factor by grouping, it's not going to be able to work. So I have to revert back to other things that I know. And what you're going to use is that possible rational root list, that P over Q. So my P could either be 1 or 2, and my Q could be 1, 3, 5, or 15. So to find the list of all the possible rational roots, I have plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 1 over 3, plus or minus 2 over 3, plus or minus 1 over 5, plus or minus 2 over 5, and then plus or minus 1 over 15, and plus or minus 2 over 15. Now, all the rational roots of this polynomial are somewhere in this list. So in order for it to be a root, or in order for it to be a zero, it would have to divide, when you divide it, it'd have to be a remainder of 0. So what we're going to do, we're going to start checking them. And the first one that we get to be a remainder of 0, that's going to be the first root that I found. Notice this is a cubic, okay, which means there are 3 roots for this polynomial total. I'm going to go to the next page and continue there. So I'm going to start trying synthetic division to see if any of these are my actual roots. So I'm going to start with positive 1, and I have 15, negative 32, positive 3, and 2 as my coefficients. Remember, there aren't any missing terms here. So I'm going to bring down the 15, multiply it with 1. Negative 32 plus 15 becomes negative 17, times negative 1 is negative 17. That becomes negative 14, and negative 14, and that's negative 12. Well, because the remainder was not 0, that means the 1 is not a root. So then I'm going to go to the next one. Well, before I move to 2, I got to check negative 1. I'm going to go ahead and do this quickly. If you need to pause it, you can. 15 times negative 1 is negative 15. That becomes negative 47, positive 47, 50, negative 50, and negative 48. So that doesn't work either. So then I'm going to go my next one, which is positive 2. And bring down the 15, that becomes 30, negative 2, negative 4, negative 1, negative 2, and they cancel out to be 0. That's my remainder. So that means that 2 is a root. And what I have left because it was a cubic to begin with, now I have the quadratic, 15x squared minus 2x minus 1. Once you get it down to a quadratic, then you don't have to use the synthetic division anymore, and at that point you can go ahead and solve the quadratic by your tools that you have, either factoring or quadratic formula. If it can factor, you factor it. If it can't, use the quadratic formula. So in this one, it is able to be factored, and you'd have to use the AC method or the T-chart though, because the A is not a 1. And you get 5x plus 1 times 3x minus 1. And to find the roots, remember it's the same as finding the zeros. I would still need to go ahead and solve these. I'm going to go to the next page for it. So I set them each equal to 0 and solve. And my roots for the polynomial are going to be x equals negative 1 over 5, positive 1/3, and don't forget the 0 or the root that worked when we were checking the synthetic division, which was positive 2. So that is all the roots of the polynomial. And notice there are 3. There are 3 because it was a cubic, so that means I have all of them there. Okay, here's one for you to try. Go ahead and list the P over Q's, and then start checking to see which one is a root first. Remember, you're only going to have to find one because it's a cubic, and then it will become a quadratic, and you can then solve that quadratic. Go ahead and pause it. I'll go ahead and show you the answers, and I'll work it out and give you the answer in a second. Okay, so here are the list of possible rational roots. When you go ahead and check 1, that doesn't work. Check -1, that does. And then you have this quadratic 2x squared minus x minus 6. So then when you factor that, that becomes 2x plus 3 times x minus 2. And when you solve that, you have x is equal to 2, x is equal to -3 over 2, and the -1 that you originally got. And those are the roots of the polynomial. And notice all of these are here in this group. They're all rational roots.